Hello, everyone. We're very excited to have you all join us for today's webinar, How to Automate Network Services and Ensure Configuration Compliance with Itential. To kick things off today, let's start with some introductions. My name is Rich Martin, and I'm the Senior Technical Marketing Engineer at Itential. And I'm very excited to be joined by one of Itential's partners, Fierce Software, with Eric Updegrove, their General Manager.
Howdy do.
Hey, it's good to hear from you, Rick. Eric, good to see you too. Also, before we get started with today's webinar, just please know that you can drop any questions into the question panel along the way, and we'll answer them in our Q&A session at the end. And with that, let's get started.
Yes, thank you, Rich. And we would first like to say thank you again to the entire Itential public sector team for joining Fierce Software and leading today's webinar agenda. So you'll see in front of you, Fierce Software is a public sector value-added reseller of IT software and hardware. We represent market disruptive technologies in DevSecOps, data analytics, and automation verticals. As a proud woman-owned small business, we help government agencies and system integrators by making license fulfillment more efficient and serving as a vendor resource aggregator. We consider ourselves more than a reseller, and our core capabilities are helping customers manage vendor engagements, pinpointing innovative technologies, supporting execution with robust enablement, and keeping track of program licenses. All of these are core capabilities that are delivered at no additional cost to our customers. And in building our vendor portfolio, we constantly monitor the commercial market for tools that will serve our public sector customers' best interests. We look for market-leading companies that are committed to participating in the unique government market. And our position in the government channel gives Fierce a broader perspective. It allows us the distance to see how tools can be integrated with best practices, and in doing so, serve organizations as catalysts for success. From this vantage point, we believe Itential is the leader in network automation. Our team is very excited to introduce Itential as the latest addition to Fierce Software's solution line card. And with that, I'm pleased to hand it back over to Rich as he walks us through today's agenda, how to automate network services and ensure configuration compliance.
Thank you very much, Eric. Appreciate that introduction. So at Itential, just like Eric said, we're really a leader in intelligent automation software, especially around network, multi-domain network, multi-vendor networks. One of the core competencies we have is reducing a skills gap that network engineers have today around how to automate all of the network changes that need to be done without having to write code. Now, that being said, we're going to show you how, if you're already integrated into writing code with a lot of these useful tools out there, how you can integrate that back into the Itential platform, because we believe that automation is a good thing, and we want to enable more automation across the broader team. So we have a low-code solution that allows you to do true end-to-end automation across network, along with integrating config and compliance into this. And one of our philosophies is that you must have configuration compliance and standardization based into your automation if you want to enable scalability and security. And that's key for every agency out there. So with that, some of our history is you'll find us at the heart of network automation for 6 out of the 10 largest service providers in the world. We are already today trusted by the U.S. military, also with U.S. financial institutions. And, combined, there are hundreds of millions of processes automated with our software. And I'm coming to you live from headquarters in Atlanta. And with that, let's continue on. We've got a lot of great stuff to cover. So getting into the kind of the meat of what we want to talk about today, and then ultimately what I want to show you, is like, what are the challenges with current network service processes? Everything starts off with a service request of some sort, in some sort of ITSM system. ServiceNow being one of the ones that we work with quite a bit, but integration, as you'll see in a minute, is in our platform is another key competency, which makes it easy to integrate whatever that ecosystem of network and IT systems every agency has, can be automated and used here. But really, when you kind of tear down the process, you have quite a few things going on. Even for the most simple of network changes, there's kind of this phase of data gathering. And so my background has been as a network engineer for many years in the trenches. And when we get a request for a network change, usually it's multiple network changes that need to be done, maybe because we're deploying a new site or some sort of application needs to be provisioned across the network. So the first step is I've got to gather all kinds of data, right? And this is kind of that swivel chair effect. What are the different systems that me as a network engineer I have to go and visit to grab the information that I need, right? So we have sources of truth. We have all kinds of data, maybe an inventory system. So I'm gathering data. That's a swivel chair where I may be clicking across multiple applications. That does take quite a considerable amount of time, but it's a required first step. And then before I actually can make a change, as a networking person, we need to make sure operationally, before we make a change, that the network is in the right state, prepared to accept that change. And sometimes that could be a different group manually doing a check to make sure that you're okay to make that change because the state of the network is this way. So there's some investigation that needs to be done. Usually a series of show commands to determine, based off of the nature of the change, that it's okay to make that change, because that piece is a big one, right? We want to avoid network interruptions, and overwriting something that already exists in the network, an interface or an IP address, is something that typically you want to do beforehand before you make the change. Otherwise, it's much more painful to have to recover from that. Then you actually get to the point where you can make the change. That could be, again, a different group altogether using a different set of tools. And this is really where we find a lot of networking teams focused in their automation efforts. So if their strategy is around automating much of the day-to-day change in their network, they're usually gravitating towards a series of tools to help them accomplish that. And that's perfectly fine. These are great tools. But really, when you step back and look at this whole process, that's where a lot of these tools tend to fall short, is being able to integrate with all of these things, whether it's with sources of truth or ticketing systems or messaging. That becomes very difficult to extend task-based automation, as what we would call it, making the actual automated change and including all of these other systems. So they will use these tools to do the automation of the task, and that's perfectly great. We want to continue to be able to allow folks to use the right tool for the right job, just like they are using the right IT systems across the organizations and agencies. After the change is made, you don't just shut the terminal off and walk away. You actually have to make sure that change was made. So we would call that the manual post check. What operationally do I need to look at in the network or a network device or set of devices to ensure the change that I made actually took place and is now operating correctly, and ideally without impacting anything else. And then as we get closer to the end of this, there could be things where we need to manually update adjacent systems. If I'm bringing up a new site, maybe I have to do some DNS stuff, or I have to go back to a source of truth and mark an IP address as being used, update it with some details, those kind of things. And then finally, every ticket that is open needs to be documented, updated, and closed. And then we can finally call that request complete. Now, if you look at this whole process, again, a lot of times we're just focused on the network engineers focused on making the change, but there's a whole lot of other processes going on that tend to take lots of time. And in an environment where you are making lots of changes all the time, you can create backlog very quickly. And so our solution addresses all of this, but allows network engineers to get started very quickly as they expand the automations out to more of an end-to-end solution. So we're going to take that normal, typical process, even of the simplest changes, and show you how The Itential platform can allow networking teams to build automations using existing network change tools, network change automations. It could be a Python script. That's what we're going to look at today, using that to actually do a change, but also surrounding it with pre-checks, post-checks, um, sources of truth, integration with ticketing systems. But instead of inundating everybody with all of that all at once, it really makes more sense to show the journey, the stepwise progression on how to get there. Starting because we want to enable the networking teams at your agencies to be able to get involved and get integrated into all of this without requiring them to write code. And so getting them started firmly as a foundation is a key component to what I want to show you today. And so there's quite a few parts to our portfolio. We are going to spend most of our time inside the automation platform, which is that middle box there, where we're going to look at Configuration Manager, which allows us to build golden configuration templates. Automation Studio, where you can build automations in a drag and drop way, and I'll talk a little bit about Operations Manager, where we can look at how automations run and then publish them externally. But we're also going to touch a bit on the Itential Automation Gateway. We won't delve deeply into it, but that's where we can now onboard any existing applications or automation scripts that the network team might already be utilizing, because we can use those automation assets and bring them into our platform as steps in a workflow, just like we do anything else natively. Those can now be integrated in and used by your teams. And then what we also have available today, because one of our philosophies is how do we get our customers to get started quickly? So we provide a lot of out-of-the-box pre-built automations, adapters, and transformations. So adapters are integrations into other systems. So all the other systems that we're talking about today, ServiceNow, NetBox, Microsoft Teams, we provide a entire library of existing automations that you can download into the platform and start to use and connect to these devices and automate them through APIs. We also have a way for our customers to generate their own automations if they have an API, a published API specification like Swagger or OpenAPI. They can generate their own, so they're not beholden to us to create an adapter for them. They can integrate them. They can create their own integrations. Also, you can download pre-built automations. These are things like doing config backups, software upgrades, making changes to ports. So these are true automations that do real work on the network that are available. And finally, transformations. We'll talk a little bit about this in the demo itself, which will become more clear. But a transformation is how we can quickly manipulate data so that it comes out of one particular task, manipulate it so that it can be used in another task. Usually this is done programmatically. We want to make it easy, again, addressing a skills gap, and visually, so that it can be very easy to manipulate data so that a step in an automation later in the workflow can now use that data correctly and appropriately the way it's defined to be used, without having to write code to do it. And these things are also reusable. So that makes it very, very easy for all of our customers to get started. And with that, let me switch over and we can get to our demo. All right. So here we're starting in the Itential Automation Platform. Now, one of the things I mentioned just a moment ago was the fact that it is vitally important that any network automation, especially an automation that's built to scale, to do so uh, uh, without opening up the opportunity to make, to override some sort of um, standard that already exists. Meaning, we need configuration compliance to be integrated into automation in order to make it secure and scalable. Just writing a script to make changes, you still need some sort of, in order to run the script even at scale, you still need some sort of overview to make sure that the changes that are made are being made correctly, but also according to a standard, security standard or operational standard that your agency may have. And so that's the key component. So whenever you're looking at doing network automation at scale, you have to integrate configuration compliance into that whole process. That's really the safest and most effective way. And going forward, this should be a standard and a best practice for all agencies. So with that, let's start off in an area of our platform called Configuration Manager. Now, in Configuration Manager, we have an inventory of devices that are unknown and on the network that I have onboarded. They could be. We support multi-vendor, multi-domain. So I have Cisco iOS devices. We have Arista devices. We have Junos devices, and so could be legacy CLI, traditional CLI managed devices, or if you're thinking about like SD-WAN, there are devices around that, but they're usually front ended by a controller, and that controller uses APIs to communicate with it programmatically, web front end as well. But we can also use integrate with these controllers and be aware of the devices behind them as well. So all of that can be used and is important so that we can build golden configuration standards. So from here, just as part of our overall solution, you can do things like backup. We can go to our device backups and see where everything has been backed up in the past. But really, where we want to drive with this is once we have devices onboarded, we want to be able to build golden configuration templates, because everything in this part of our platform can be utilized in an automation when we go to the next part of this demo, in Automation Studio, where we actually build out things, build the automations out. We can actually reference all the work that's being done here as part of a compliance check before we actually do an automation. Again, this is how you must integrate these things together in order to give you the most secure network possible. So let me go over here to a golden configuration, and we're going to build a golden configuration on the fly and utilize it in the demonstration. So I want to flip over here. So this is a Cisco iOS STIG that's published by a Cisco employee. He actually writes the STIG validator that's is used all over the place, and he's posted a list of configurations that pass the latest STIG validator program that he has. And so I want to use this because what this means is that these are the baseline security standards that every network device needs to follow. So if it passes that configuration, if it passes that validation, then this configuration is compliant. And so we can actually use this as a starting point to build a golden configuration that we can now use inside of our application into our platform. And so the first thing I can do is, if you look at this configuration, this is very specific to a very unique device. But again, it passes the validation check if you run the STIG checking program that's published here. But we can use this. But one thing you'll notice, especially if legacy processes usually have some sort of standards checking program, but in order to do that, it's an offline check. Usually you're pulling configurations off of all of your devices. You're running against an analyzer to validate whether this meets the current industry security standards. And if it doesn't, it spits out where it's missing configurations. But if you think about that, that's really not a good way to build golden configurations. That's actually a golden configuration for every single device on the network. And so one of the things that we've done kind of as a new way of looking at this, and an easier way to manage all this, is if you look at a series of network devices, especially if they're like devices, you'll notice that there's a series of configuration commands that are really just baseline. They're very much globally relevant to all these device types. And then you may get to a series of configurations that are unique to a function in the network. Core network devices need to have these things. Maybe they're running BGP, but on edge devices, maybe they're not. And then you'll have configurations that may be more localized, maybe to a region, right? Devices in Atlanta need to be in this subnet because that's what we've defined as our standard. And so what we've done with Configuration Manager is given you the ability to build that kind of flexible golden configurations template. You can base it off of STIG, and then you can also incorporate all of your local operational standards into the same golden configuration. And the really cool thing about that is now it is relevant not to just one device, but to many devices. And so let's build that out. So I won't take the baseline configuration of everything here, but I will take a subsection of it. We'll go to here. And I'll go back to Configuration Manager. And I want you to think of this as a baseline configuration. So I can go into the configuration tab here, and I can just paste in everything that I took from this this STIG compliant configuration. And now this should be globally relevant to any Cisco layer 3 iOS device that I have built for this golden configuration. And so I save that. Now we can take a look at something more relevant to, let's say, where this device is in the network, its function, you could say. So I can add a child node to this, rename it to something like core. Oops. Now I have a child node that resides under this baseline configuration. So now that I'm there, what you'll notice is that I inherit all of the baseline configurations that we've defined on the Cisco IOS L3 router. But now I can implement standards that are relevant to something in the core network. So let's say, for instance, we have an operational standard that says devices in the core network need to have syslog not only turned on, but on a very specific host, right? This is the secure syslog server that we have for our core routers. Maybe we want to separate those out. So now I can define a configuration line that's relevant to these core devices, and I can save that. And at the same time, I could also do something like I could add another child. And then this one, we can rename to Edge. So now Edge Cisco devices would have a different syslog server separated out. And now my standards now get to, instead of having one golden configuration standard for every device, now I can start to build out more functional devices, standards that are more functional across many devices. And now we can create more and more of these child nodes as we want to structure and architect these golden configurations. So in this case, I can give it a geography. So if I'm here in Atlanta, I can do something like this. And now we've started to build something out that is that includes baseline security definitions as defined by the latest STIG for these particular types of Cisco devices, as well as operational standards like syslog hosts, could be NTP hosts, could be a number of things that must be there. And then we can drive that all the way down into configuration, part of the golden config for configuration that's unique to, say, core devices in Atlanta. But I'm going to stop right here and show you that at this point, we can add devices to this tree structure. And so this is the one we'll be working on here. And so I've added this device, which is a Cisco IOS device. Its golden configuration template is what we just created here. It's going to compare its current configuration, if I run a compliance report, to that template we've just created. And now we can start to add devices, and we can add devices at any part of the tree. And it will inherit based off of the configurations that have already been defined, both above it and at that level in the tree. And in this case, everything passed with a compliance check, and that's great. But let's put something even more relevant in there, because when we look at, like, how do network devices get out of sync? They drift from their standard. There's a couple things going on. It happens over time. A lot of times it's human error, and we want to be able to avoid that human error. So that's why not only do we want to build the configurations around security standards, but also around operational standards. And sometimes you have operational standards that look like this. So if we have interfaces, as an example, in Atlanta, maybe we want to relegate them to certain naming conventions. Just for example, here we're going to use loopbacks because they're easy to demo on. But in this case, I'm defining a standard for Atlanta that says when we create a loopback interface in Atlanta, it has to be in the 300 range. And you'll notice we're using regular expression matches. So in our compliance engine, we allow you to actually integrate more dynamic rules into this. So we're using regular expression matches to ensure that loopback can be defined in the 300 range. And this one always happens. We create an interface without a description. Well, we want to avoid that, because for troubleshooting, we want to be able to look at the description and at least give us a clue as what's going on, especially if it's a 4 a.m. troubleshooting session. We want as much detail as possible. So let's make sure as a standard now that a description matches ATL, the string ATL ID, and then some string after that. Maybe it's some sort of unique identifier to that service or that particular function. And then because networks can't just pick any IP they want, they're subnetted and routed in a very particular way. We want to ensure that anytime somebody makes a loopback interface on this, it is in the correct it's in the correct IP range. And that IP range we're using here is 10.10.30, in that range with a /32 net mask. And so now we've created very locally relevant rules and standards in our compliance engine. And so I mentioned earlier how things get out of sync is human error, but also there's another side to it. If you look at like the STIG that was published for like a Cisco iOS router a year ago, it's different from what it is today. Things get added. And so one of the things that is very unique to the way now we're doing this in this new methodology is I can go to that baseline config, and as things get added into the standard, I can add those new things here in the standard in one place. And because of the nature of this, it gets inherited into everything below it, which makes it very easy now. You're not managing thousands of golden configs. You're managing one golden config for a set of routers and device types, perhaps. It makes it very easy to update and make changes. And again, because of that, because of the inherited nature of this also gets inherited into this edge branch right here. So as we go down, I can add more as the standards become more defined. I can go back to this and add into this. And I want to think about maybe there's another group that's in charge of this. And we'll visit that in just a second, that can be in charge of ensuring that these rules are always standardized and up to date, so that when automations are run, they're going to reference these rules before even a change is made. And that's a powerful thing that every network team really needs to integrate into their automations. All right, so we have that done. We've added that device to it. We've created this compliance rule set here just on the fly. Now let's move over into another area of our platform called Automation Studio. So this is our low code. You want to think about it as a canvas with a drag and drop interface. And if you think back to that slide I showed where the networking team is focusing on automating that network task, that's what this looks like. So right in the middle of this, it's make the network change. So this is one step in an automation process. And technically, this is actually calling a Python script that lives on on the automation gateway, which I talked about a little bit earlier, which allows you to onboard existing automations, whether Ansible, Python, Terraform, whatever tools that your team's using. And now they can be used as a step in an automation on our platform. But running this by itself would still require somebody to manually do a pre-check process, meaning before this change is made, I still need to make sure the network's okay. So really what we want to do is we want to define a pre-check before we make the change. And then after we make the change, we want to define a post-check process, meaning if I pass the pre-check process, which means the network was in the correct state to make the change, then I can actually make the change. But instead of disconnecting at that point, I want to go back, do some operational commands to make sure that the change that I actually made on the network is correct. And so you really want to post-check. Now, that's part of the full automation stack for the networking team to be able to do, but we actually want to add more to it. And this is where we tie in all of the configuration that we did in Configuration Manager, all of that compliance, all of the STIG standards that we need to integrate. What we can do is we want to validate, what we call validate the network changes. And this is a critical concept. What this means is before we even engage in a pre-check, We want to take the proposed configuration changes that'll be made in this step, send them to our configuration manager compliance engine, and ask that if this change were to be made on this particular device, would it violate any of those security standards? Would it violate any of our operational standards? Would it violate any of the standards we have defined for things like loopback interfaces and that we just configured? That is a important step that every network automation needs to have. Why? Because it gives you a preventative measure. So if I already have a network that's compliant, I want to help remove as much human error as possible. And so this step will ensure that we can, again, preventatively remove human error as much as possible, for sure, by validating a change before it's even made. So the output of that would say, yes, if you were to apply this, it would not validate any. I mean, it wouldn't cross over any standards that we already have defined in this compliance tree that we have, or it may come back and say, oh yes, it does. It does overrun it. You should make this change. And then from that point, if it passes, then we should be able to do a pre-check, which looks at the operational data, make the change, and then the post-check. So I've just stubbed that out exactly the way we would normally start working in automation, build an automation. That's precisely what we do. We use this as a canvas, we stub it out. Now let me walk you through what this looks like now that we start to formalize all of these other these steps, because now you can see where we're adding a little bit more to this. And let's start with that validation. So it starts first with a transformation that's going to take some data. So what do we need in order to make a change to the network? In this case, we're going to create a new interface, a loopback. We need the device that's going to be the change is going to be put on. Again, gathering data. Think back to gathering data. What is the device that we need to put this on? What is the name of the loopback? What is the IP address? What is the net mask? Oh, and we need a description. So all that information has to be inputted from a variety of sources. In this case, it'll be a form and a source of truth that I'll talk about in a moment. But we want to format. So a transformation allows us to take that data from even multiple sources and put it into a way that can be used by a step in the workflow. So in this case, we're going to format the CLI commands that will actually be executed so that we can pass that to this validate network change step. That goes back into our configuration manager and that underlying engine to now compare those configuration changes that we propose to our standard that we just defined. And it's going to come back and give us a result. That result, again, gets transformed so we can use that. But ultimately, we're making a decision here. That decision says the compliance engine said it doesn't invalidate anything, continue on. Or it's going to tell us, nope, the compliance engine said, don't make that change. If you do, it will invalidate something. And in this case, we're going to be able to view the error and exactly what it invalidates. From that point, we can now run the pre-check. So what is a pre-check? A pre-check in this case can be a number of things, but one of the really unique things that we have in Itential's platform, again, if you think about, we want to be able to allow our customers, especially network engineers, who really don't want to write code. Some of them do, but the majority of them don't, and they're so busy during the day. Writing code to automate is just that there's not enough time. And so what we want to do is we want to be able to take that operational knowledge that they have. So if this is a pre-check and I'm about to make a decision, I need to make a decision on whether or not I can make this loopback, new loopback interface on this particular device. A network engineer is going to think about, well, if I'm on the command line, what's the first thing I'm going to look at operationally before I make that change? And it's going to look something like a process, right? It's going to say, well, the first thing I would do is I need to show the interfaces on that device to make sure that interface doesn't already exist. So we can literally take the same commands that they would normally execute on the command line without having to write any code. And we can do the show interface command, and we're going to variabilize the interface name from a form that's part of the platform and the transformation, but we're going to variabilize that. So now it's going to actually execute the same command they would execute based off of their own MOP, and it's going to do a show interface for this particular loopback. So what would I expect to find? And now if I'm doing this process manually, well, the first thing I would look for is if I do a show interface for a loopback and it actually says it's up, and it shouldn't be up, then I shouldn't make the change. Why? Because if that interface already exists and I expect it to not exist, this be a net new thing, then by making a change on that device, I might change the IP address. And if I do that, I might disrupt the service that's already running. So we need to put the brakes on that immediately. So that's what the rules do. The rule says execute this command and then look for, in this case, it says it must not contain the interfaces up, which means that the Cisco device, the Cisco router in this case, is not going to recognize that interface as existing. So this is a pre-check. Now we can build this out with multiple steps. It could be a completely different process. We want to be able to allow a network engineer to use that embedded knowledge of the operational state and the process that they would use and start to build that into a very, very robust pre-check process before you make any change. So we do the validation step to ensure we don't override any compliance rules. Now we're doing an operational pre-check that a network engineer can sit down and express in this as well. So that's a pre-check. So what does a post-check look like? Well, in this case, it's going to look very similar. So if it meets the pre-check condition that the interface doesn't exist, then I can make the change. Now, as a post-check, I can use this command template feature in our platform to show the same interface again, but this time we want to make sure it contains the interfaces up. So the logic here is before I make the change, the interface shouldn't exist. Makes sense. We make the change. Can't disconnect now. Need to make sure that now that the router operationally says that the interface is up. Not only that, we've added a second step. Out of the same output of this show interface command, not only do we need to see it's up, we need to also make sure that the IP address is the same IP address that we've defined. Now, again, we could have fleshed this out to many more steps. Whatever your MOP looks like, you need to apply that here. But as a demonstration of the feature and the function and how networking teams can get started very quickly, this should illustrate the point. And so now let's go back to this, to the workflow that we've built out. We've started with the first part of the demo, kind of stubbing this out. Now we've added our pre-checks. We're getting the result from the pre-check condition. If it passes the condition, then it's going to go to our next step down here. But if it doesn't, we can send it back to a rollback procedure so that no changes are made, things can get updated. Tickets can get updated or things like that. But at the very least, we want to pump the brakes on this and say something isn't right. So now we have two fallout scenarios. We don't want to override their compliance rules for that particular device. And we want to make sure operationally everything's in place before we make the change. So ideally, then we go and make the change. Everything is passed at that point. And now we can do something critical that's unfortunately not done as often as it needs to, back up the device configuration because that's an insurance policy. So we want to do that as a step. Then we can actually make the change. Then we could run our post check to ensure the change was made, and we can get down, transform the results to make a decision. Now, if the decision was something didn't go right with that post check, meaning we did the show interface, the loopback either didn't show up or a different IP didn't show, then we can actually have another robust process to roll everything back, even using that backup device config that we just made. So this is how you can progress and start to build not just the network automation, but also all of the guardrails that are necessary to do this at scale. So let's run it. So we've done the work with building the compliance. So when I run this, we go into we can take a look at the job, and it's going to show us step by step what's going on in the process. So we also have the ability to do manual tasks, meaning the automation stops and allows us to either view data or provide input. So I told you that the input for creating an interface has got to come from a different source, right? So we need things like what device it's on. So in the platform, we can create forms, and in the forms, we can actually validate the input as well. So now here's another level of guardrail to validate input so that even if we provide a form, we can make sure that the input of the form matches, validates and matches what we expect. So for instance, I can do a drop down here and limit the devices that are available to make this change to. Under interface name, we're going to use loopback 301. That meets our standard. And under description, we're going to also I pre-filled these out so they meet a standard. That also gives another ability to make sure that we reduce as much human error as possible. But in this case, everything conforms to the standard because I want to make the interface to begin with. So I want this to successfully run through just to show how everything flows. And then we'll go through and we'll take a look at the failover or the failout options. So right now it's executing at the step it's at now is validating network change. So again, we've formatted using the data that we've got, we've formatted the device to the CLI commands that are going to be executed. We've asked our engine, compliance engine, to say, hey, would this override any kind of STIG or operational standard? It came back, completed. The validation decision was made. It did not take the error, so it was within the validations, within our standards. It ran the pre-check. The pre-check passed because it did not go back here and roll it over. So that means the interface didn't already exist. Now we're doing a backup configuration. So we're on the success path here. Now it's making the change, which is actually running a Python script to make a change. So we can integrate all of that asset, all those automation assets you may already have. If not, we can do this natively in the platform as well with a task. And then eventually it's going to run this post check. It's going to make the decision. So this is going to verify that the change we actually intended to make was made. And then it's going to come back and do the post check decision, which should take us to the end of the automation. And it's completed. And once it's completed, you can refresh it and you can see the success path down here. Everything, any path it didn't take is grayed out. All right, so that was a success path, but we put these guardrails in for a reason. If you're going to scale network automation and do it without creating human error or allowing human error to creep in, we want to make sure that our guardrails work correctly. So the first thing we can do is we can rerun this again and intentionally make a human error. So remember, our standard was to define that loopbacks must be in a particular numerical region, right, the 300s, but in this case, a description, because this always happens. Somebody puts a nonsense description or no description at all that doesn't help anybody. So now if I run this automation again, what we'll see is, we'll go back to our visualize. This is not going to be a valid, when we go to the validation decision here, this is going to not adhere to our compliance standard, right? Remember, we built a loopback compliance standard using regular expression matches that says you must have a description, and the description at a minimum must match this string, ATL ID. And so now the validation error is hit, and it's actually running. So I can go to a manual task now because it's stopping at this blue task because I want to notify the person that this has failed. And where is it failed? It's failed because it didn't meet the description compliance rule that we had set. So if I continue this, it will take the fail path and exit out without making any changes. And so now you can see how important that is to be able to validate before any automation is done. This helps to keep a network that is in compliance, keep it to stay in compliance, because over time, human error can cause it to drift. Now, our last guardrail here is the pre-check. And remember, the pre-check was before I make a change to this loop back, make sure it doesn't already exist. Well, we've already created it in the first iteration. So let's run it one last time and show how that now can be used to ensure that we don't inadvertently make changes to the network and cause problems. So in this case, I'm going to leave everything as is to conform to the validation standard step that we defined. We'll go back to visualize, and we can take a look at where it is. So this should pass the validation check because it's looking at the syntax to make sure that it's validated. But now we go to the operational information, and the operational information in the pre-check says, oh, this loopback already exists. And so we're running that pre-check test now. And remember, this is something a network engineer, without writing any code, just out of the information in their head, could have expressed into a compliance template and built into this, providing value right from the very beginning. So it hit the pre-check decision, and it went this way. And let me refresh it because it's already completed. But now you can see It passed the validation check, as it should, but during the pre-check evaluation, it said that loopback existed, so we're not going to make that, and it went to the rollback, which took us to the very end and didn't make any change at all. So that's how you can, as a very next step, start to integrate um, pre-check, post-check processes that any network engineer could sit down, build command templates on, to be a valuable addition to scaling these automations safely. And again, one of the unique processes here that we have that we believe is absolutely necessary for scalable network automations is the ability to validate a network change before it's made. This ties back to your ability to do golden configuration templates that are based off of the latest STIG standards and your own operational standards that every agency sets. So being able to do that as a step before any change is done is important to ensuring networks stay in compliance. Now, let's go to one final step. So we talked about being an end-to-end automation solution. So now we're going to be able to bring in information and integration from a variety of sources, because the end-to-end piece now would include things like, how do we integrate with your ITSM, your change management system? In this case, we're going to use ServiceNow. Getting IP addresses from a source of truth. Technically, that IP address actually, even in the last demo, came from our source of truth, which is in this case a NetBox device that's set up as an IPAM. So it's doing our IP address management. But that's a part of this as well. It's part of that data gathering. We're also integrating into this network notification. So we're doing real-time notifications in MS Teams as an automation progresses. This is great. Communications is important. Everybody needs to know, and in the applications or the environments that they're using, when automations are occurring, perhaps an operations team needs to be aware of an automation that's running so that they don't do anything that might impact that. So being able to extend your automation into the communications and notifications tools that your agency is using important, as well as surrounding it with um, um, ticket management. And again, that's a big part of it. Every network change now, the change control process is another guardrail. But how do we make it more efficient? If we can build it into the automation, then we can make it as efficient as possible. And so that's what's going on here. So now we're going to get some information from a form like we did before. We're going to pull an IP address, reducing human error so that we don't have to manually type in an IP address. We're going to open a ticket in ServiceNow. We're going to receive the ticket ID back from ServiceNow. We're going to broadcast that in our MS Teams so that the team can be aware of what's going on. Then we're going to go through the same process that I showed you in the second step of this demo, the thing that we talked about, stubbed out, and then built out, where we're now doing a very secure change, because it's secure, because we're checking to make sure it doesn't override a standard. We're checking to make sure operationally with our pre-check that it doesn't clobber anything before we even make the change. And then we're making sure after the change is made, there's the change, that our post-check process is also clean. And then when that's done, we can close out the ticket and move on. And so that's the entire demo we're going to. And if you think about this is a journey, right? You start with, especially when we're focusing on the network team, how do we get them quickly to engage in the automation without requiring them to learn lots and lots of code? Then once we've done that, we want to make sure it's safe and secure. You got your pre-checks, your post-checks, your validation. Now we can start to layer in more of these systems and then make this automation even more efficient and scalable. So we can run this right now. And we'll show how it will integrate with all those systems. So the first thing is, it is getting input from a form still. So I do want to pop this form up. In this case, we already know loopback 301 exists. So if I run it with 301 again, well, it's going to give me an error and I want it to pass through. So I'm going to use loopback 302, which does not clobber our compliance standard because it's in the correct range, 300 to 399. In this case, I'll give it a a new description that adheres to the standard, and then we'll run the automation. So now the first thing it's done is it's opened a ticket, and now it's done a notification in MS Teams. And now it's waiting for approval. So I'll go to visualize so we can kind of see it a little bit easier. So it took that information, grabbed an IP address from Netbox, opened a change management request, and then sent something out in MS Teams. So if I look at my MS Teams output here, 12:49 p.m. That's right now. It created this, and we've embedded the ticket status into there. So if this is going out to a group of your team of network engineers, they all have visibility into this. And now I can click on the ServiceNow ticket, and I can see where it's at in the process. And again, the change management is part of a guardrail and a process to reduce human error and make sure things are done right the first time. So now we have this whole process that we're integrating with on ServiceNow. And right now we're at new. So let's run this process through pretty quickly. So I can go through here. Normally this would take multiple people, depending on the process and the nature of the change. At this point, the change is waiting approval. So then somebody would come in, an approver would come in here, approve this change. This should update it and now move it. So we went from new to assess to authorize. So this is another level of request. So a change is waiting approval. We go down here. Now one of these people get to make the approval here. So Ron's going to make that approval for us. He's going to move this ticket forward. Now we're in the scheduled. So normally you would go in here and schedule this, but we want to be able to implement it immediately. Now one note here is, when we go back to where we're at, we'll go to details. Let's take a look at the job that's running. It's actually sitting here waiting for approval. So what does that mean? That means that in ServiceNow, we're waiting for these steps to get done, scheduled, and implemented, and then we're allowed to run the automation. So instead of a ticket sitting there and waiting because the process is being done, and maybe I'm inundated as the network engineer and I'm not up to date with the tickets, you can actually integrate to the point where your automation can take a look and see if the ticket's been is moved to a state where you're allowed to implement. And that's really what we're doing here as an example. So now if I go to implement, meaning just we're going to schedule this for right now, we've hit the implementation stage. So now if I go back to here, it was waiting for CR approval. If we go to visualize, it should show us that it's now moving beyond that. Yeah, here it is. So we were waiting for that approval at this step. Now it's completed because we hit implementation stage in ServiceNow. We were integrating it, just querying it to see if the state had updated to allow us to go. And now the automation is moving forward. It's passed the validation check because we're adhering to the standards for this particular change. It's running the pre-check. That pre-check was the show interface to see if it exists. It doesn't exist because we identified a new interface, 302, for the loopback. Now it's doing the device backup. That's your insurance policy, just in case you need it. And then eventually it's going to make the network change after it does the backup, run the post-check process. And so what is the post-check process? That means we do another show interface. Loopback 302 should exist, and not only should exist, it should have the correct IP address that was defined by the application, or the source of truth, which is here as a netbox. And then so finally, it's going to run the post check. And the very last step of this is once it passes the post check, it's going to close out the ServiceNow ticket. And so that's a very much time-saving process. Different organizations and agencies implement these things, based off of, what their process is. But the whole point of this was to illustrate that this can be done in a flexible way based off of what your needs are. And so that's been done. Let's go back to the ServiceNow request. You can see that we got to the implementation stage, and our automation actually moved this forward because it did the pre-check, the post-check. That's part of a review process in this case. And then it went ahead and closed the ticket out. And so really that's the journey, and that's the end of the demo. So let me transition back. One moment. Okay. And finally, say that we talked a little bit earlier about that we're in a lot of service providers, we're in the public sector, we're in finance, specifically in the public sector. Many agencies that are using us have been able to remove hundreds of days and thousands of hours just automating this. So think about that end-to-end process. It's not just about the network task. That is important. But now when you start to expand this out to integrating your change request system, your source of truth, reducing the amount of time it takes to gather data, automation is about getting things done fast, absolutely, but you need to make sure they're done right and they're done securely. We're not clobbering any standards. And so being able to do that for our customers, especially like if you're doing new deployments, so zero touch deployments, zero touch provisioning, also day zero and day one automated configuration of layer 3 VPNs. We are multi-domain. We do not just CLI devices, but we integrate with API based solutions, network and IT systems. And so we can support many network devices and services. And also beyond just day zero, day one type deployments, being able to do day two. So everything I showed you in Configuration Manager could apply to your day one deployment, making sure network devices are standardized, but also over time ensuring that configuration drift doesn't happen, either by making sure there's an easy way to update your standard as the STIG standards are updated, and making sure that every change that's done through automation is checked before anything is actually applied to the network. And then we also have other government agencies that and partners that find that not only once they get started in our environment, that the work that they've done is reusable. So we talked about that pre-built library. So our customers start to build their own automations, their own transformations, and creating their own reusable libraries. So some of the functions and steps that I've used in in the demonstration today was from our pre-built library, which originated from our own proof of concept team. And so we also make those available to our customers through that pre-built library I talked about earlier. And again, configuration and compliance, provisioning, service requests, that's all of the things we do. We want to allow network engineers to get quickly started in the environment, not use a lot of code or not have to write any code, but also over time, make your automations more and more efficient by integrating more and more of these systems. And that's something that's unique to us, and that's something we do very, very well. And so I know we only have a couple minutes left for some Q&A. I'm going to take let's see, I got a couple questions here. Let me take this one. Can a command template connect to multiple network devices and run commands? So when I talked about command templates, they were the heart of what I showed as a pre-check and post-check. That is something that's very easy for network engineers to start to work on. I showed that it's just basically the CLI commands that they would execute. A command template is unique to a specific device because the intention is those are the commands that you're going to run on that very specific device. Now, here's the thing. I showed one step of a command template. Or actually, I showed in the command template for post check, I showed 2 steps, but you could actually run several command templates. So let's say I'm doing a network change that is across multiple devices. Then I could probably do a command template or I probably would do a command template for device A and device B, assuming I'm making changes on those. And those command templates would be pre-checks and post-checks. So a single command template is relevant to a single device at that time. But because we're an automation workflow, it's very simple to just create a new node, a step in that workflow to do a second command template for another device as part of your pre and post check. One more question real quick. Where is the device configuration backed up to, and how do I access it? Very good question. So it's backed up to our platform, essentially in a database, but you access it through the configuration manager. There was a tab on the left that allows you to take a look at the backups. I may have stopped by there briefly. Your backup, so when you do an automated backup or even a manual backup within configuration manager, it's accessible there. So you can pull it up. It's also accessible through the automation. Like we have functions that allow you to pull old backup configurations or previous backup configurations. So if you think about the automation that we did, one of the steps, I call it the insurance policy, is making up a backup. Your rollback procedure of your post check could be to pull that backup in the automation to pull that back up and then restore the changes that were made so that you can revert it back. And we have, we've helped customers, and customers have done that as well. All right, I think we're at time. Thank you very much. And I wanted to say thank you to Eric with Fierce Software for joining me today. Appreciate it.
Thanks for having me, Rich. And thanks for everyone for joining us.
Yeah, absolutely. And if you have any questions, our information's here. And you can obviously find us at itential.com. We look forward to hearing from you. And we want to thank you so much for your time and joining today's webinar. If we didn't get to your question, we'll be sure to follow up by email. And if you do have any further questions, please make sure you reach out to your team or to our team. And our information is there. Thank you once again, and have a great day.